Here we have an RCA Victor AM All-American 5 tube radio from the early 50s, probably 51, 52. The complaint on this one, this was sent in by a friend of mine who watches these videos. So anyway, the complaint was on this set, it hums. So pretty much, we can pretty much figure out what that is already. I'm sure it's got some dead filter capacitors in it, so that's what we're looking at as a start. So let's plug it in and listen to it hum. Oh yeah, unmistakable filter cap hum. Well, we are getting a station behind the hum, so that's promising. Alright, let's pull the back off of it and see what it needs. And here's the chassis, pulled straight out from the cabinet. This one's built a little strange and looks like it's going to be a pain in the butt to work on. Looks like the way they got this thing set up, you got to take these nuts out of the tuner. And looks like you probably got to take the speaker out. Probably leave these nuts attached and take these out of this side of the speaker. And you got to take all these out, and you got some down on that side over there with the volume knob, and all comes out the side. So yeah, they don't want you getting in this one. And the filter cap it's not, you know, external at all, so it must be under here. Okay, then the chassis. The underside of the chassis is finally exposed when you remove the front plate of this set. And here we have our filter capacitor. So let's see what we got here. So we have a 50 and a 30 microfarad and 150 working volts. So let's see if we can find an easy way to replace this capacitor. Well, I'll replace the electrolytic capacitors, and now we have a new problem with it. No reception and the classic sign of SMD. For those of you who do not know what SMD is, it's silver mica disease, and the IF transformers have silver mica capacitors built into them. Over the years, that thin layer of silver mica degrades and you get what they call SMD, silver mica disease, and you get the sound of a thunderstorm crackling effect. And the only thing you can do, since these IF transformers probably haven't been available in 40 or 50 years at the very least, the only thing you can do is go in and try and rebuild, or take out these mica sheets that are inside here, remove the old capacitor and install a new external capacitor on the legs or either inside the transformer itself. That's the only way you can get around it. So I guess at this point we will try to disassemble the IF transformer and try to remove the old sheet of mica capacitor inside the IF transformer. I did let the customer know about this and they said to go ahead and try to fix it, so we're going to go ahead and see what we can do about getting this problem resolved. Now what you're going to want to do before you remove this is mark where the can was positioned at, so you'll know which direction it came out of, so you can insert it back the same way. And you're also going to want to carry that mark through to the bottom part that you're disassembling, so you know where it goes. Just make you a little mark with a Sharpie or something like that, so you know where it goes. Alright. Okay, we have the transformer removed. Now this type of transformer, I saw a video on YouTube not too long ago on a guy that did some of these. These are made by Automatic Manufacturing Corporation. It's right there on the bottom. And this is the type that has a silver mica cap under here, under this metal plate, which is on a plastic cover. The silver mica caps are sandwiched between this plastic cover where my fingernail is and the bottom of it. Now in order to remove this, you have to drill out this rivet and push this through, and to be able to get to the silver mica sheets, which is what makes the capacitor. In order to drill this out, it's pretty delicate work. I mean, you know, if you break this plastic or these real thin wires that are right there, you're pretty much done for. So let me analyze this situation and see what all it's going to take. I don't think there's any other way that I can do this. You know, if there was a way to terminate these pins right here and continue the wire, the contact of the wire, but not the mica cap inside, I would do that. But I don't think there's going to be any way to terminate those metal pins in there, you know, before they go under there and reach the cap. The main goal here is to take the cap out of line. And I think even if I was able just to disable one pin on each contact point where the capacitor is, I think that yeah, that would at least take it out of the circuit. Okay, I was able to get the rivet drilled out. Took quite a bit of drilling. The rivet tends to want to spin around in the hole down there. So I already removed the mica sheet. I had a lot of the rivet drilled out in the part, this plastic cap moved up, so I stuck a screwdriver in there and dug it out. But the problem is you got to get your pins cut so they don't contact each other. And I had to melt this one back together because I ended up snapping off the corner there, but I melted it over so it'll hold. But yeah, these things are just clear plastic. Now the plastic seems a little, you know, fairly sturdy for even as old as it is, but you know, you never want a chance putting too much strength on just plastic that's, you know, 60, you know, plus years old. So anyway, now I just need to trim these legs down right here so they don't contact each other, because right now they're overlapping, just like I did here, where they're not contacting each other. And then we'll put this plastic piece back in, and what I'll do is just hit a couple of the corners and melt it, you know, like plastic weld it together, just like I did with that leg there. We'll just melt the corners here, put that plastic piece back in, because these legs tend to want to move up and down because there's no support now, because all the support was from this rivet and plastic piece. Because basically these things just flop around. So you can see how they just flop around like that. Okay, it's not pretty, but plastic covers back on the top, and I just melted the corners together with a soldering iron. So I ohmed them out, and they're still 19 ohms between each pin, so should be ready to go back in the can here. Well, after that IF can removal, we get to do the same thing to the other IF can. Same thing with the other IF can, still the same crackling. So we did the first IF transformer, now we can do the second one. Let me go ahead and get this thing unplugged and get started pulling this can out. Well, after wrestling this thing out of here, I go to look, and there's no mica caps on the bottom. There's no mica sheet, or, you know, the thin sheet of mica. None under there. It's on top, like right below the top of the can, the screw for the top of the can. So, you know, I'm wondering if there's any under here, and there's not. You can kind of see that from the bottom anyway. I think that's the first time I've run into one of these with it on the top like that, but anyway. It's got your 3 legs that go all the way up. This has got to be just for the capacitor. You do have some sort of contacts here. You got wires going here, but I mean, theoretically you really probably could cut those legs, but I don't know, this might come off the top. I think that holds the screw in there, so it'd probably just be better just to bend these, maybe cut those out of there and get that mica sheet out. But from what I understood, and from what I've seen in the schematic, I think this is actually supposed to have 3 capacitors, but I only see 2 sections. Okay, what I want to show you, I'm going to try to move this light over here with this IF can. I got the mica sheet out. It was pretty easy. I can't do this one-handed, so I just had to turn the camera off. But, you know, as you saw before, these tabs were bent down, and this mica sheet was under it. Well, there is actually a 3rd mica sheet under that one. I wanted to point that out to anybody that's doing these cans. I don't know if you can see that sheet. I'm sure you probably can. I'm looking through a little bitty tiny screen here on the viewfinder. But right here is another sheet where there's a capacitor between, it looks like, this point and this point. So there's 2 here. So I believe that you got a level of capacitance between here and here, from what I can tell. I'm gonna have to get that sheet out of there to be sure, but I believe that's how this is working here. Oops. I believe this is between here and here, because this will rest on top of here as well as this. So I took some capacitance readings, but I couldn't get a stable enough reading to tell what was going on with this sheet in here. I mean, it's just trying to get an accurate reading off a bad capacitor to begin with. It's just not, you know, I've seen videos where these people try to take readings off of these, and yeah, you can probably get a reading somewhat, but you know, I found more the case, and the capacitor is already bad anyway. It's kind of hard to get an accurate reading off of it. But on this one, the schematic indicates, you know, the capacitance. In this one, a lot of the schematics with these types of cans don't indicate the capacitance. And I hope I'm not wrong about this, but let's see here. Well, this is the first IF can that we already did. But this is where we're at here. I believe this is 131 for this capacitor, and this dot indicates inside the can here. You have your coils, and then you have this 106 here, and then you have this 155 here, which I believe to be this one here, because I determined that this is pin 5 on here, which is the schematic. This is pin 5, so this would be the 155, and pin 1 would be 106. Okay, I've got the two mica sheets out. I did have to chop these off. They're out, so I just chopped these off so there's no continuity, nothing's getting crossed up with anything, and these just go to nowhere. So that's done. But yeah, on these, I mean, you could definitely tell this was protected by this, because this was on top of this. So yeah, this is the color, the white color is the color it's supposed to be. You can see where the pins were all over this, but the rest of this is just black and oxidized. So what it is that just that mica inside that, you know, that mica material they're using in there just degrades. It's such a thin, really super thin, you know, layer of mica. It just breaks down over the years, and that's how you get SMD right there. Just nowadays, this is really causing the death of a lot of 1950s tube radios. Any of these radios that you buy with these small IF cans like this, be very, very leery. You know, these things are very prone to mica, SMD, silver mica disease. Has become quite a problem within the last several years. You know, these old tube radios, as all this stuff gets old, you really, really have to be passionate with trying to keep this stuff going. Well, we got our IF can installed back in the radio, and I got our capacitor soldered in place. I'm just using these disc capacitors. That's all I really have. I do have some mica caps on the way. I may, you know, go back in there and change them back out to mica caps, but you know, a lot of the newer tube radios from, I don't know, the late 50s through the mid 60s had a lot of these disc caps, and they work just fine. So we're gonna go with these, and we got 100 picofarad, 100 picofarad on the got 200 picofarad on the first IF can. Then according to the schematic here, you know, number 5 was 155 picofarad, which I only have, of course, 150. This 106 from 1 to 2, I went with 100. And then you got, I think, 131 or something like that. I couldn't quite make it out. I just went with 100 on that. We'll see how that works out. If it doesn't work, you know, got some mica caps on the way. I could always just go to a 150 or a 120 on that, and, you know, kind of change it out if I can't adjust the IF can to peak out, then we can always adjust the cap a little bit. But that's what we have on hand. You know, 400 picofarads and 150 picofarads. So we'll go with that and see. Let's plug it in and see if she works. We're getting reception a little bit.
Earlier, she's on the ground there, saying things are going very well. It seems very under control. Everybody feels completely safe, and they're having a great time. I want to get back to one of our callers who
well, she's playing again.
Explaining how the justice system is
Old School 93.3.
going on and why these crimes aren't actually coming to fulfillment. Dr. Dave from Alabama, can you go ahead and explain it to us? Because I really have a need to
understand. That's that Christian station that's a mile up the road, and it'll blast you out. Let's hook I'm going to try to hook me up an external antenna and see if I can get this thing to pick up a little bit better. Well, external antenna really didn't help the matter, so I went ahead and peeked some of the coils out just by ear. I got a signal generator over here, but I still need to, it needs repair. It's not working right now, so I just had to do it by ear. It should be good enough. I noticed some distortion in the audio, even on, you know, nearby channels on it. So I'm gonna check a couple of resistors and some capacitors and stuff in the audio circuit and see if that'll help anything. Well, I went to power the radio back up after going to change a couple of the last paper capacitors in here, and it was dead. So took the signal tracer and traced it from the front end of the radio to the second IF transformer. The same thing we had just opened up to get rid of the silver mica disease, and found a broken wire. See if I can look through the magnifying. I don't know if you can see that. Let's see. It's this wire here, right where I'm kind of pointing my finger, right where it goes on to the, okay, that's the secondary winding, because that the other one's where it comes in at. Where the signal comes in at, it was fine, but it wasn't leaving the transformer. I ohmed it out, and it ohmed out, the secondary winding ohmed out open. So I knew I had to have a broken wire somewhere. So I figured I'd take the transformer out and look at it and see if I could find a broken wire anywhere close to where it's soldered at. And I found the wire going back to pin 1 open. So that's where the opening was at. Wasn't getting back to that leg, so that's actually pin 1's where it actually leaves the transformer. So I'm gonna have to see if I can try to do some microscopic soldering. I don't know if I'm gonna be able to do this or not. Other than that, we may have to replace the transformer. And as you know, these transformers are not easy to find. Okay, back on this RCA with the silver mica problems. I got this junker here, this beauty, this clock radio beauty, on eBay for parts. So I got this thing on eBay, got it for parts. So I'm gonna harvest the IF transformer out of it to go in our, this will be the donor for this set here. And I could probably use a few more parts out of this set too, other than just the IFs. But it has the same style IFs as the old one did right there. So hopefully this is going to work for us. I actually got this set to come on and work. It was listed as not working, but you know, really, I mean, who cares with this kind of damage on the case? It doesn't really matter. It's pretty much junk anyway, but it does play. But you know, I actually had to, when I got it, so I had to clean the rat's nest out of the inside of it. Yeah, so that's just great. And of course this wasn't broken before they shipped it, because nobody can pack a radio on eBay and ship it. These people need to go back to packing school and learn how to pack a radio. If I needed this back for another one of these clock radios, I would be really mad. Okay, I got our other IF can out, and this one's made a little different on the inside, whereas the other one had the mica sheets on top. This one's got them on the bottom. Well, good news, our old IF doesn't have any connection to the windings on the center third leg. It's just there for capacitance. So I don't see why this one wouldn't work. We're just going to have to disable the internal sheet in this one. Even though the radio worked, as you can see, that mica is really blackened down in there, so it would probably be better just to go ahead and extract the sheet out. But I'm going to have to be very careful because these wires are really close on this one, and as I know from experience, they're very brittle or fragile. So wish me luck. Okay, I've got our first layer of mica sheet removed. Now we've got our second layer, which goes to our center pin here, right here, and attaches. There's a sheet, probably ain't gonna focus, but there's a sheet up under these pins here, and this thing ain't gonna stand up. Up under these pins here, there's another layer. So I'm gonna have to chop off these ones that were at the top and the ones at the bottom after I get that bottom sheet out. So let me finish this up here. Okay, here's our IF transformer with the sheets removed and all the leads clipped so they don't touch each other or anything else. So let's go ahead and put this back in the can and put it in the radio. Then I've got some silver mica caps that came in for this, so I'll just use those. It's going to end up being 200 picofarads and 150 picofarad on that center pin there. Okay, we got our new IF transformer installed in the radio with our mica caps soldered to each point. There's the other one way down in there. Got that all done. So there's our new IF can, or our donor can from our donor radio over here. So all the tubes are put back in, so let's plug it in and see if it works. Well, we have static from the speaker. That's a good sign. Hey, it works. Must have knocked the talk radio station off the air. I'm having some storms come through here. Well, that sounds good after all that work. Good to save a radio that was just about not going to be able to be saved. The wire inside of this old IF transformer broke, and I didn't think I could find anything else that'll work. So,
carrying 12 soldiers overturned in a fast-flowing flooded creek during a training exercise, killing 5 and leaving 4 missing. Texas Governor Greg Abbott says the tragic deaths of the soldiers illustrate the dangers of high water.
well, the radio's recapped, so I think we can go ahead and put it back together and proceed with the alignment procedure on it, because to be honest with you, I'm about ready to be done with this project. This has gone on way too long. Okay, we have our signal generator set to 455 kilocycles, and we're ready to begin the alignment procedure. I'm injecting a signal into the 12BA6 IF tube. Stand by. Okay, got it all back in the cabinet, playing. We've got a whole lot of stuff coming in tonight. The band's kind of dead. Camera sounds like it's making noise.
Price comes in about 12, 7 hits and 33 at bats.
There's a little bit of stuff fading in and out.
Trying to put you down.
A lot of camera interference.
Tearing flat of the country and beating my fellow Americans to a pulp, defenseless Americans.
Okay, there's the
When I watch them burning
1952 RCA
that my grandfather fought for.
pain in the butt that I've been working on for over a week now.
And I watch the SEIU
Back in the cabinet playing, hopefully for another long time.
help organize this mob and the leftists and all the rest of them.